Hello everybody. Today I'm going to shoot a video on trigonometry ratios. Now, before we can really get into trig ratios, you need to know, what exactly we're talking about when we mean trig. So, trigonometry is used to find missing side lengths or angle measures for right triangles. Now, technically, there are a total of 6 trigonometric functions. We have sine, cosine, tangent. We have what's called cosecant, secant, and cotangent. And these are the 6 trigonometric functions. Each of them are designed to be used depending on what you're given. Some require you to use what's called the hypotenuse, if you recall. If you don't remember, real quick, the hypotenuse is the longest side of a right triangle, and it's the side directly opposite the 90-degree angle. So some of these functions require knowing this length. Others require knowing one of the 2 other lengths. And all of this is usually in relation to a particular angle. And we'll talk more about that later in this video. Now, for our purposes, and basically for an intro in trigonometry, we're going to focus on these 3. We are not going to deal with these 3, over here. So, now, first up, when we talk about the trig functions, math people are very, very, very lazy. And for each of these trig functions, we actually have a bit of shorthand. Tangent is, shortened to tan. Cosine is shortened to cos, COS. And believe it or not, sine is shortened to sin. I know, it's only 4 letters, but for some reason, math people have decided to shorten everything down to 3 letters. I don't know, maybe to be consistent, something like that. So, anyways, now, for your 3 basic trig functions here, like I said, each of them is used to find certain side lengths and or angle measures. It really depends on the information you're asked to find and the information you've been provided. To start off, we're just going to start by knowing what the trig ratios are. All right, so real quick, you're going to see a lot of, when you deal with trigonometry, you're going to see a lot of symbols. Now, these symbols are typically used for when we are writing angle measures. And here are some Greek letters for you. So, if you see a circle with a line going horizontally through it, this is actually what we call theta. And this is one of the more common symbols to use when we're referring to an angle. So for example, in this triangle here, if I was asked to find a trig ratio given this was my reference angle, then you would see theta in this corner. So, this symbol here is the Greek letter for alpha, and B here, if you haven't guessed it, is the Greek letter for beta. So, each of these symbols, they're used basically for the same thing. They're used to represent either an unknown angle measure or to provide you a reference given what the question's asking. So, like I said, the first thing we're going to do is to determine some ratios of a given trig function. Now, this is all well and good, but in order to do this, you've got to understand a few things. So, here's a 3, 4, 5 right triangle real quick. And for sanity's sake, let's say that this bottom right one is my reference angle. This is my theta. For me, I'm pretty much just going to use theta exclusively in this video. Sorry about that. But you, like I said, you can use any of these. I'm not very good at writing in alpha, and well, my handwriting's not very good, and I can't usually fit a beta in a very small angle, so I'll probably just use theta. Anyways, though, off topic. So, like I said, we're going to actually figure out what the trig ratios for this particular triangle would be. Now, a ratio is essentially just a fraction, guys. You know, it's one number divided by another number. Now, we've got to know, you know, roughly what are the rules for finding the ratios for a given trig function. Well, it really will depend on where a reference angle is, because depending where the reference angle is depends on where a few other things are. So real quick, I'm just going to draw another one, and this one I'm going to fill in with no numbers. So like we mentioned a moment ago, this is my hypotenuse. Actually, I could just use this one up here, I just realized, but hey, hypotenuse. I'm thinking there's an E after that end. I don't know. I'm never good at spelling hypotenuse. So, anyways. So, the hypotenuse is always going to be, like I said, the longest side, the side across from 90, yada, 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 yada. Well, the other two sides here that actually we would give them a special name. If our reference angle is down here, then the side that touches both the 90-degree angle and this reference angle here, this is what we call the adjacent side. Why do we call it adjacent? Well, adjacent simply means to be beside something else. So, the adjacent is beside the reference angle. And this side over here, we call this the opposite side. Why do we call it opposite? Well, because it is opposite from where the reference angle is. It does not touch it at all, and it is essentially across from it. So these are the three side lengths that we're going to have to focus on understanding first. So, like I said, the hypotenuse is always across from the 90. The adjacent is always touching the reference angle and the 90-degree angle. And the opposite side does not touch the reference angle at all. It only will touch the 90, but never the reference angle. So, now, why did I just tell you that? Well, like I said, all the three of these trig functions form a ratio. Now, all three of those ratios can basically be broken down into two of these three sides, whether it's opposite divided by the hypotenuse, the adjacent divided by the hypotenuse, or opposite divided by the adjacent. There are a few other combinations you could probably come up with looking at this, but those are actually the three combinations we're going to be working with here. So, let's start with sine. Sine, its ratio is actually opposite divided by hypotenuse. So, anytime you're referencing the sine of an angle, You want to know what the opposite side is, and you want to know what the hypotenuse is. So if we're looking at this example here, our theta, if you look at this for a second, you could probably figure out what the ratio is. The hypotenuse is the easiest spot. It's the side across from 90, or in other words, the longest length. The longest length is 5, and it's across from the 90. So 5 will go on the bottom here. Now the opposite side, it's not necessarily always going to be the shortest side, or the shorter of the two remaining sides. It could be the longer of the two remaining sides. The side length for it doesn't matter. As long as you are not touching the reference angle, then that's your opposite side. In this case, the opposite side is 3. So then the sine of theta, or in other words, the opposite side divided by the hypotenuse, simplifies to about 3/5, or about 0.6. This is what the sine of whatever number this angle is would equivalent out to. Sine is actually a function, and it can, the sine of a particular angle actually outputs a certain number. In this case, it would output 3 divided by 5, or approximately 0.6. So, but that's if we knew what this reference angle was. At this time, we don't know it. So, without that, we don't know what this is without actually writing down the ratio. The next one we're going to look at is cosine of theta. Now, the cosine of theta uses the adjacent side divided by the hypotenuse. So this one uses the side that touches theta, or a reference angle, and the 90-degree angle, and it utilizes the hypotenuse still. So in this case, the bottom, as you can guess, is still going to be 5, but this time I'm going to use 4. So this would be about 4/5. Sorry about that again. Unfortunately, there's going to be a lot of bells in this video, because this video will not be short. Alright, the next one we're going to talk about, and this will be the last trig function we're going to be dealing with, is tangent of theta. Now, for this one's a little weird. This one uses the opposite and the adjacent. It utilizes both of them. Well, the opposite we found was 3 earlier. The adjacent we found was 4. So then this would be 3/4. And these would be the ratios. So if someone asks you to find, the sine of theta, or they ask you to find the cosine of theta, or something to that effect, what they're asking you to do is, hey, tell me what that ratio is, given that reference angle. Tell me what, if it's sine, tell me what the opposite divided by the hypotenuse is. If it's cosine, tell me what the adjacent divided by the hypotenuse, or tangent, opposite divided by the adjacent. Now, if you're struggling with following this, honestly, don't feel bad. This is one of those that I actually think is pretty hard for people to understand the first time around. So this takes some practice, guys. So don't worry about it. Now, one thing that people always struggle with, though, is remembering what each trig function is. Sine of theta. Which two side lengths does that use? Is it adjacent over opposite? Is it or cosine, is it opposite over adjacent? People get those confused pretty often. So because of that, there have been a few different ways that people can have decided to remind themselves of the combination of letters. So, one way, and this is one of the more common methods, is SOHCAHTOA. SOHCAHTOA, you can remind, is simply sine is opposite over hypotenuse. So, cosine is adjacent over hypotenuse, and TOA, which is tangent, is opposite over adjacent. Some people call this SOHCAHTOA, so that's you. However, those aren't the two ways I remember it. The one way I remember it, and it's a beautiful, beautiful way, is some old hippie caught another hippie tripping on acid. Let me say it again. Some old hippie caught another hippie tripping on acid. It's something silly, but it helps a lot of people to remember what this is. If you're going into engineering or into a math central background, you're likely going to need to use trigonometry at some point. So I highly advise you to memorize this, because that way you're not having to reference back to a lot of things. There are many formulas and many different things in algebra and geometry. A lot of them you can always refer back to. It's not a big deal. One thing I've always encouraged people to do is trigonometry. Know which function applies to which ratio. If you know the ratio for a particular function, you don't have to sit there and puzzle it out. It's very quick. It gets you through the problem. So, there you go. Real quick, let's look at another example, and we'll just try to find the ratio of that. So, for this one, let's say that these are the three side lengths for this function, and this time, sorry about that, this time let's say our reference angle is actually up there. You can't rely on the reference angle always being at the bottom. You just can't. Don't assume the reference angle is always on the bottom. Sometimes it will be up top. Now, I will say this though. The reference angle will never, ever be the 90-degree angle. Ever. So, never use the 90-degree angle as your reference angle. The angles you want is either going to be this one or this one. It's going to be one of the two acute angles. One of the angles that looks less than 90 degrees. Now, real quick, we're going to write what the sine, cosine, and tangent of theta is. So if you want, at this point, pause the video, see if you can figure out what they are really quick before I do them. Alright, assuming you just pause the video to figure out what they are, let's figure it out. So we'll start with the sine. So the sine of theta, remember, sine is opposite over hypotenuse. Some old hippie. So you need to know which side is which. Well, the hypotenuse is the easiest one to figure out. Hypotenuse is always the side across from 90. It's the largest one. In this case, that's 17. Now remember, opposite sometimes the shorter of the two remaining sides, sometimes the longer. In all honesty, it doesn't matter. As long as you know which side is opposite of your theta, which side is not touching the theta, your reference angle. In this case, the 8 is actually touching the reference angle, which means the 15 is not. So this side here is my opposite. which makes this my adjacent. So, in that case, that means sine of theta is 15 divided by 17. Now, side note, pro tip, if you make a ratio and the fraction can simplify, then you simplify it. That's standard practice. If a fraction can simplify, then you simplify it. In this case, 15 over 17 does not. In fact, I'm fairly certain none of these will. Cosine of theta, that's adjacent over hypotenuse. You know, we caught another hippie. So that would be 8 over 17. And then finally, tangent. So we're tripping on acid here. So tangent of theta is opposite over adjacent. Or in other words, 15 divided by 8. And none of these simplify. So that's as far as we can go. Ta-da! So there you go. Now, sometimes you're given a problem that actually has no numbers. Like for instance, this one, and they're just labeled as A, B, C, and let's say our reference angle is down here. And they'll ask you, hey, what's sine of theta, cosine of theta, tangent of theta? Guys, for a problem like this, just do it the same way. Figure out what each side is. You know, in this case, B is hypotenuse, A is opposite, C is adjacent. And sine of theta is going to be our opposite over hypotenuse, so A over B. Cosine of theta is C over B. Tangent of theta is A over C. There you go. You know, it doesn't matter if it has numbers or not. If they ask you to find certain functions of a reference angle, just give them whatever that reference angle should be. If it's opposite over hypotenuse, give them that. If it's opposite over adjacent, give them that. Whatever they want, give it to them. All right? Now, sometimes, though, problems aren't very nice to us. And sometimes we'll get a problem where we have certain side lengths, but not everyone. And they'll actually ask us, hey, I want you to go through and I want you to tell me, you know, find the sine of theta. Okay, so that's a little tougher because sine of theta, that's supposed to be opposite over hypotenuse. And if we go through this real quick, well, 5 is hypotenuse, 4 is the adjacent, but x here, you know, this unknown side is opposite. You know, sometimes there won't even be an x here. Sometimes it'll just be blank, and you have to fill in the x yourself. So, how do we go about figuring out that opposite side? Well, in geometry, there is one formula that is used more than any other formula is used. You know, it can be applied to a number of different situations because the thing is, right triangles can be made pretty much anywhere. And that formula is the Pythagorean theorem. If you do not remember it, the Pythagorean theorem was devised to find a missing side of a right triangle. And the formula is a squared plus b squared equals c squared. Now, quick reminder, c is always the hypotenuse here in this formula. C is always the hypotenuse here. A and B are the other two sides. It does not matter which one you set for A or which one is B. You know, the opposite, it doesn't matter if you always use A for your opposite and B as your adjacent or vice versa. It does not matter. It will not change the way you have to solve this. So, for this problem, we actually have to utilize the Pythagorean theorem first before we can actually write the ratio for this function. So, here's how we do it. As I said a moment ago, 5 is the hypotenuse and C is the hypotenuse. So I'm going to fill in 5 for C. Now, it does not matter which is X and which is 4 here. Simply pick. I like my variable to be written first, so I'll do that first. Now, next up, I'm going to evaluate it. So I'm going to do 4 squared, which is 16. 5 squared is 25. You know, this is just 4 times 4 and 5 times 5. Now, I'm going to take my next step up here. I need to get x squared by itself. So that means I need to move 16 over to the other side. So x squared equals 9. And then I've got to take the square root of 9, because the way I cancel out a square is by utilizing a square root. Now, if you're using your phone for this, it's not a problem. You can still make use of it, but you need to have your rotation on, because we need to pull up this symbol, square root symbol. So if you use an Android, then all you have to do is type the square root of 9 and you get 3. Now, if you're using an iPhone, I believe you have to hit the 3 first and then the square root button. The 9 and then the square root. Excuse me, we want to get 3. So that means that we get our x is 3. So I'll go over here, I'll fill in x. Therefore, the sine of theta, and yes, you want to put the theta in. Okay, you don't necessarily need to put theta in parentheses here. If this was an angle measure, though, we would. So for me, as you can see with the way I write my trig functions here, I've kind of gotten in the habit of putting the reference angle in parentheses. You don't have to, but it's something I've done. So anyway, sine of theta. Sine of theta, sine is opposite over hypotenuse, so it's 3 divided by 5. And that's it. Now this is one where I had to do a little bit of moving around. We'll do one more real quick to show you. So let's say that's 6, this is 8, and this is my theta. And let's say I want to find the cosine of theta. I didn't leave myself a lot of room here, but I should be fine. So, cosine of theta for this, you know, cosine is adjacent over hypotenuse. And again, if we label this, 8 is my adjacent, 6 is the opposite, and the blank is the hypotenuse. So I need to find the hypotenuse this time. This is my unknown. For sanity's sake, I'll put an X there. Now, if I set up, first thing I'm going to do is I got to set up my Pythagorean theorem. Now this time I don't have the hypotenuse, so I'm going to fill in X for C. My other two side lengths were 8 and 6. So I'll do 6 squared plus 8 squared. Now I'll evaluate. 6 squared is 36. 8 squared is 64 equals x squared. Add those two together, you get 100 equals x squared. Cancel a square with a square root. You get x is 10. Therefore, the cosine of theta is 8 divided by 10. Now, 8 over 10 does simplify. Therefore, divide them both by 2, and you make cosine of theta equal to 4/5. And that is all I have. So, there is a lot to trigonometry, as you can see, and this is essentially baby trigonometry. But if you got confused over anything, that's okay. This happens. Trigonometry can be tricky to get a hold of at first. But once you got a handle on trig, it actually does start to get a little bit easier. But you got to get a hold on it now. So, go back through, rewatch parts of this video if you need to. If you have a question or something you understand, leave a comment, send me a message, and I'll get back to you. Beyond that, guys and gals, that's all I have. Okay? So, remember, some old hippie caught another hippie tripping on acid. Don't you be doing that, though. And I'll talk to you all later. Okay? Take care now.